So today we'll discuss the automata. So we have a three kind of automatas, right? So one is deterministic finite automata DFA, and we have a NFA, and we have a Epsilon NFA. Okay. This is what is the difference of all three automatas. Empty move is not at all allowed in DFA, in NFA also, but Epsilon NFA we can use an empty string. So all three automatas are having only the 5 attributes. So I have to find out only that 5 attributes. DFA is like a deterministic finite automata. Each state, only unique path is allowed, or only uniqueness is allowed each and every state. Unique symbol is accepted in DFA. Multiple moves allowed in NFA. Empty also allowed in Epsilon NFA. That is only the difference. For example, so the initial state can be represented by this arrow with this node. This is the initial state. And final state is used in double circle like this. Okay, these common representation we can use in all three automatas. So what is that attributes we are having? The 5 attributes is, so we are having, one is a set of states, input symbol, transition function, initial state, and final state. All three we can use a 5 attributes. So Q is like a set of states. What are all the state we used in the automata that we can write here? This is the input symbol, the edge value in the automata. This is transition function. This is initial state. And this one is a final state. Okay. The transition function alone varies the three automatas. Suppose if you are considering DFA, how the transition function will be. Transition function is, you want to move from one state to another state, I can use this function. Otherwise, or I can call it as a transition mapping. So how it will be there, you want to move from one state to another state, we need one state along with the input symbol. So using these two, I can reach to another state. So the input symbol is represented this one, right? So I can take it as this symbol. So it will move to only one state. If you are considering DFA, I can get only, I am going to use only uniqueness, right? So a single path only I'm going to consider for each state. So I'll get only one move. From one state, one input symbol. So it goes to only one state. This is DFA. The transition function for NFA is the same thing, right? Here is also, I want to move from one state to another state. So the state is Q. Input symbol is this notation. But for this NFA, multiple moves are allowed from each and every state. Okay. So in that situation, I can take it as a power set 2 per Q. And for one more format is we are having Epsilon NFA, right? So Epsilon NFA, how can I represent is multiple moves only, right? State, input symbol. The input symbol itself, I can use an empty string also. The output is same thing. It is a multiple moves. That's it. So this is only the difference of three automatas: DFA, NFA, and Epsilon NFA. Okay. We'll see one example for each automata, how we can design these automatas. Let's start with DFA. Okay. So I want to design a DFA for 3 consecutive ones. Question is 3 consecutive ones. Over the input symbol is 0, 1. Okay, I'm having zeros and ones, but constraint is multiple consecutive 3 ones are I have to design using DFA. So consecutive 3 ones. So I'll start it from, you first check out how many input symbols we are having for our constraints. 3 input symbol, right? So for that, you can add, you have to draw n plus 1 states. 3 means you have to draw 4 states. So I'll take it as Q0, Q1, Q2, and Q3. Okay, 4 state it is there, right? So each edge you have to use only one input symbol, only recognized at a time. Now our constraint is satisfied. What is the initial state here? Q0. What is the final state? Q3. In between, I have used 2 different states. Now the zero is also allowed inside my automata. So for that situation, this is DFA. So for Q0 to Q1, already one symbol is recognized in this Q0. One more symbol, I can use it. That symbol is 0. So I'm going to give a self loop like this. Okay, self loop is also called as a clean closure. It recognizes 0 or more number of this symbol. Sometime it will be considered or sometime it won't consider. So now Q0 recognized both input symbol only one time. So this is satisfied DFA. Like that, you take it as a Q1. Already one is recognized, right? One more symbol we have to place it. Suppose I am giving here 0 means it will affect your constraint. What will happen means I am considering this is a 0 here. So what will happen? It will consider as 0, 1, 0, 1, 1. We cannot get like a 3 consecutive zeros, right? 0, 1, 0, 1, 1. There is no consecutive 3 ones. That situation, don't do this one. I'll remove this. Okay. But I can give from Q1 to Q0 as 0. This is possible. You check out. Suppose this is, I'm executing, I recognized only one time. So you'll get 0 followed by this one. And followed by, I want this 0 also. So 0, remaining 3 ones. From here to here, so 3 ones. Yes, we have a consecutive 3 ones. Like that. For this Q2s also, if you are going to give a self loop, sure, it will affect your constraint. So for that situation, I can start from here to here. I'll give it my input symbol as 0. Okay. The end I can give like a one input symbol I can give, that is a 0. But okay, if you want to give a 1 from here to here, you can give. This is also correct. So each and every state, whatever input symbol we are having, if it is not effective or constraint, you can include. Otherwise, you can leave it. Okay, this is 3 consecutive ones for this problem. Suppose I have one more language, n a power 0 power n, such that n mod 3 is equal to 2. Okay. Now I want 0 is my input symbol, right? But I want I need that n value. If you know n value, I can easily draw the diagram. For that n value, they have given some constraint. So n mod 3 is equal to 2. So how can I find this n value is n mod 3 is equal to 2, right? Suppose I'm substituting n value is equal to 2. Okay, I'll get 2, right? This is what we want, right? Whatever value you can substitute, but the output should be is equal to 2 means I can consider that value as an n value. So here I'm considering my n value as 2. So my output is also 2. This is satisfied. Another one is I'll consider as 3 mod 3, but the value is equal to 0, right? What is the output we need? 2. So this is not, we cannot take n as a 3. 4 is also what will happen. 4 mod 3 is equal to, it will give 1. Okay, this is also not satisfied based on our constraint. But I'll substitute 5. 5 mod 3, so you'll get 2. Right? So this is satisfied. So one n value is already in this place, that is 2. Another n value is, that is 5. What is the next value? 6, not possible. 7 also not possible. 8 is possible, right? 8 mod 3, I'll get 2. So I'll take another value as 8. So like that it will goes, right? So now your n value is, you have some 3 values you are having. 2, 5, 8. What is the next value is? I think 11. 11 mod 3 will get 2. Okay. So now I need a diagram for these n values equal to, that meaning is n values we calculated. Now the language is 0 power 2, 0 power 5, 0 power 8, 0 power 11, like that it will goes. Okay. How can we draw the diagram for this one? So what is the base value here that I have to mark it first? Base value is 2 zeros. 2 0 in the sense, how many states is needed? So 3 states, right? So I'll start from Q0. 2 state means n plus 1. 2 input symbol means n plus 1 states. Okay, n input symbol, n plus 1 state. Like that you can take assumption. So here is Q2. 2 input symbol only. Okay, so 3 state you can take it. Here you can consider as a final state. So 0, 0. The first base symbol is accepted, right? 2 zeros accepted in this automata. What is the next 0? 5 zeros, right? So I started from here to here. The input symbol, you can give it a 0. Now you can check it whether 5 0 is accepted in this automata. Start from initial state. 1, 2, 3, 4, 5. Yes, 5 0 is accepted. Check out 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 also accepted. This is 8, no? 9, 10, 11. 11 is also accepted. Okay, so all possible, the given input is accepted in this automata. So this is and also you check out whether it's a DFA. Yes, it's a DFA. Q0, you can, only 1 0 is recognized. Q1 is also 1 0. Q2 is also 1 0. Yes, it is a DFA. Clear this one? So it's very simple. First, you draw the diagram for your base value. Base value is 2 means you can take it as 3 state. Base value is 4 means you have to consider as 5 state. So after that, you can satisfy your constraint also. Your automata should satisfy your constraint. This is a DFA, and also you have to fill the attributes. Okay, 5 attributes we are having now. How we can fill it? That also I'll tell you. This is your diagram, right? So for this diagram, I'll tell you what are all the things you have to fill it for your attributes. First one is set of states. Okay, how many state is there? 3, no? 3 alone you can take it. One is Q0, second state is Q1, third state is Q2. Set of state is over. And input symbol of this problem is 0 alone. So 0. Okay, third attribute transition function, right? Transition function is, so you started from Q0. What is the transition from Q0 is 0 alone. So that input symbol. What is the outgoing state name? Q1. So Q0 is over. Next, you can take it as Q1. The input symbol is again 0. The outgoing state is Q2. Transition of Q2, 0, the outgoing state is Q0. That's it. So these three things is based on the transition mapping of this diagram. What is the fourth attribute? This is 1. This is second attribute. This is a third attribute. Fourth attribute is initial state. Initial state of this problem is Q0 only. What is a final state? Which one is you are having a double circle? That is a final state. So Q2 is the final state in this problem. More than one final state is allowed in the automata, but only one initial state you have to use in the automata. Okay. So next you'll see that NFA, and then we'll see the Epsilon NFA. So NFA is okay. For example, we can draw the same problem. Shall we take it? Like a 3 consecutive ones, or we can move to some other problem like starting with A, ending with B, in between any number of A's and B's over the alphabet A, comma B. Okay. Question is very simple. So you have to start with your string, start with A symbol, end with B symbol, in between any number of A's and B's. Okay. Sometimes this is one possible string. Like that, I can write A. This is only our constraint, right? Beginning with A, end with B. In between, I can use B. Or in between, I can use A also. Or in between, I can use A, B, B. Or I can take it as B, B, B. So like that, it goes. So for this, need a diagram for NFA. So I'll start with, so the base I can take initially, okay? 2 input symbols, so I'll take it as a 3 state Q1. And I'm going to consider this as a final state. So this is A, this is B. In between, maybe a A symbol is there or B symbol is there, right? This is A, this is B. This is a combination. So here I'm going to take it as A symbol I'll give. Okay. So here is also, I'm going to start with A symbol only, right? So I can give A, but I cannot give a B symbol. Suppose I'm giving B here means it will, the problem will collapse a constraint. The diagram will collapse, okay? So don't give B symbol, so, but I can give A symbol. So A symbol, this is also, I can give it as A, comma B also, I can give. In this place also, I can give A, comma B. But A is not allowed. Why? Because the constraint is end with B, no? So we cannot give a. We cannot give a A symbol, but I can give B symbol. Okay, right. Suppose whether this is NFA, it's NFA. Why? Because Q0 is recognized 2 A's. The A is recognized in multiple modes. So it's not a DFA, but it's a NFA. Like this, Q1 is also not satisfied DFA rule. It satisfies NFA rules. Why? Because B is accepted in 2 places. But Q2 is B only. one state is not satisfied DFA rules, automatically we can say this is belongs to NFA. Suppose this particular string is accepted here. How can I check it? I'll start with Q0. So Q0 to Q1, A is recognized. Q1 to Q2, A is recognized. Yes, AB is accepted. Now I want to check ABB. Okay, start from here, A. And this is B. And this is B. Okay, this is meaning is like either A or B. At a time, one symbol is recognized. AAB. So this place also I'll take it as A, this A and B. Okay. ABB. First time from this to this A and 3B is right. So 1B and 2B is recognized here. Okay, this is called as a NFA. The last one is a Epsilon NFA. So this automata is having like a empty string also. That is only the same kind of NFA, but it is having empty symbol also. For example, so I want to draw the diagram for numbers. Okay. How numbers will be there? So maybe of plus 5. This is one number. Or this is also I can take it as minus 5, minus 5. Or I'll consider 5.0 or 56 alone. Okay. Then 5e plus 2 or 56e minus 2. Okay, this is also possible in this numbers. Okay. For example, I'll start from here. Okay. So initially, I'll start at Q0. What is the first symbol I have? A plus or minus or nothing, right? So I'll consider from Q0 to Q1 plus symbol or minus symbol or empty string. Without reading any input symbol, automatically it will goes from one state to another state. That symbol is called as an empty string. Okay. Now this is for this is satisfied, right? This one or nothing. After that, we have a number, right? It may be of single digit, 5 alone or 56, or sometime I can take it as a 5, 6, 7, these 3 digit. Okay. So I'll start with one single digit as Q2. Here I'll give it as 0 to 9. So repeatedly you want, I can use it as a self loop. Why I have given like a 0 to 9 means whatever number you want, you can take it, right? From 0 to 9. This is only our general format of numbers, right? That I'm using here. And so this is for this part is over, right? This is also over. 56 also I can take it here and followed by 5, 6, 7 also I can recognize using the state and straight line and self loop. What is the next value we have is one is a decimal point, another one is like a E symbol, exponent part. So one way is I'm using a decimal part. Otherwise, one way is I'm using a exponent part. Exponent is also sometime I can use or sometime I won't use. So I'll consider the empty string also. This is Q3. Okay, for this exponent part. After recognizing this 5, it will be considering here E symbol or it won't consider E symbol here. That is key. Followed by plus or minus, right? So I'll take it as again plus symbol, minus symbol or empty string. Q4. I think I can close here. Yeah, after this plus or minus also we have a digits, right? Some digits we are having. So in that situation, I can use a self loop here, 0 to 9. So this is the exponent part is over, but we have a 5.0 or 56.0, some decimal point we are having, right? That is also there. So from here, I will take it as a decimal point. So in this place, I'm using, this is Q3, Q4. This is, I'll consider this one as 4. After decimal point, suppose I need some digit means, that is also possible, right? For example, 5.0 also after decimal point, I have some value. So in that situation, I can use a self loop here, 0 to 9. Okay, after that, I will directly move to this state or directly move to this state also. This is also possible. Okay, this is a last state. So here I'm considering Q5. So this is my final state. We'll check out, for example, I have a number is only 5. It start from Q0, empty string is recognized, and this 5 is recognized here. Then it will move, the empty is recognized, it will goes to final state. Suppose I'll give like a 98. Okay, start with here empty string. Here, first the 9 is recognized. Again, 8 is recognized here. Then empty string, it will reach a final state. Okay, this is satisfied, this is satisfied. Suppose plus 5.7. Plus is recognized in this initial state to Q1. Then 5 is recognized. Then decimal point, it will goes here, right? And 7 is recognized here. From this to this, we have to give some values, right? I'll give like an empty string. Without reading input symbol, directly it will move to one state to another state. So this is also okay. Suppose I have a 56 E symbol minus 2. So first time this is empty string, 5 is recognized, 6 is recognized, E symbol is recognized here, minus symbol is recognized, then the 2 is recognized. Whether this diagram is epsilon NFA, it's epsilon NFA. Because we have an empty string in all the edges, right? Many places. If one empty string, if you are using also, the diagram is belongs to epsilon NFA. Okay. That's it for the designing of DFA NFA on epsilon NFA. Thank you.